Way back in chapter 2, when we had those really long explanations via the code samples for um, the first of our numeric demos, the payout is here in chapter 3.3, so we don't have to repeat ourselves. The big takeaway from those exercises then was the idea of integer division. This happens in 3.3. It starts on page 100. But really what we want to talk about just very, very briefly is page 101. This one goes pretty quick, doesn't it? With integer division. Remember that in integer division, if I have two integer values, int1 and int2, int1 is 5, int2 is 2, you know that the real product there, 5 divided by 2, should be 2.5. But in integer division, because we truncate everything that happens after the decimal point, 2.5 is truncated as 2. So in integer division, 5 divided by 2 is 2. That's good enough for some things. I don't want to tell you what that's good enough for. I'll tell you it's not good enough for my bank account. I'll tell you if I'm splitting a pizza with you, I don't want the 2 pieces as opposed to 2.5 pieces. I want my other half a piece of pizza, whatever the case might be. So integer division, you just have to be aware of its shortcomings in order not to be trapped by them. When it comes to mixed cases, and really the takeaway here is rule number 2, and this is on page 100. When we have mixed types, so an integer and a float, what essentially happens is the lowest rank, and you can see here on page 100 that table, int is the lowest rank going all the way up to long double for the highest of ranks, and everything else sorts out in between. As long as we're talking about numerically, you'll notice that Boolean and char are not on here. Those aren't numeric in the same way. So if we have an integer and a float and we're doing a mathematical operation on them, int times float, when C++ is doing that math, it is going to promote the integer to a floating point. So essentially what that would mean for us is if we're multiplying 5 times 10.5, that 5 is promoted to 5.0 to be able to match that floating point number. However, if you are going to save that value back to something, and let's say that the result of that math is being saved back to an integer variable type, it's going to be promoted, or in this case, it is demoted back to that original type, so integer. So it's something to be aware of. You'll come to appreciate when that is going to happen. Do I need more specificity? Do I need less specificity? And that'll be okay. So I still stick to the strategy I wanted you to remember at the beginning is use the variable type that most appropriately fits what you are looking to do. So if, for example, a float will do instead of a double, I still think you should consider using the float. If an int will do instead of a double, please consider using the int. But do be aware that when we have different types of variables in a mathematical expression, there are times where we are going to get that promotion, but there are, in the event of saving things back to a variable, that save destination is going to have the last say in what kind of essentially number it is that you're going to get. Are you going to get a whole number? Are you going to get a decimal number? It depends on that particular program.